Welcome back for lesson 2.2. We're now going to go from looking at some different graphs. Let's see, what do we do? Bar graphs, qualitative data. We're going to look at quantitative graphs in 2.2. So let's just move there now to the notes. And we're going to start with a histogram. Histogram looks a lot like a bar chart, except for all of the bars are connected because it's quantitative and it has to go in order from smallest to largest. It consists of contiguous adjoining boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents, for instance, distance from your home to school. The vertical axis is labeled either frequency or relative frequency. The relative frequency is equal to the frequency for an observed value of the data divided by the total number of data values. So here's the calculation, but we did relative frequencies in chapter 1. So this should look familiar. So to construct a histogram, first decide how many bars or intervals, also called classes, represent the data. Many histograms consist of 5 to 15. So we're going to choose anywhere between 5 and 15 today. The number of bars needed to be chosen. Choose a starting point for the first interval to be less than the smallest data value. Now, if the data value is an even, like 60, I'm going to start at 60. If it's not, then I'm going to round down to the nearest even number. So for instance, let's go to your notes here in, because I didn't print out the most current. So it says the following data are the heights in inches of 100 male semi-professional soccer players. The heights are continuous data since height is measured. So here they are. The smallest data value is 60. So since the data with the most decimal places has one decimal, for instance, 61.5, we want our starting point to be even. So I'm just going to go with 60 because it's already a nice even number. Had it been 61.3, I would have went down to 61. The largest value is 74, so I will leave that as the ending value because it's an even integer. Okay, next you're going to calculate the width of each bar or class interval. So I did 74 minus 60, which is my upper bound minus it's my maximum number, actually my max minus my min, divided by my number of bars that I want. Okay, and we decided to go with 8 bars. You could go with 10 bars, but 8 is nice because when you take 74 minus 60 divided by 8, you get 1.75, which rounds up to a nice even 2. So I made my boundaries like this: 60, and then 62, then 64, 66, 68, 70. So I'm going to show you what it looks like in Excel. So when you go to Excel and you look here at the height of the soccer players, I put all the data in here for you to look at, and you have to put it in one column. And then you can calculate if you want to do it using Excel, you could. I just put my, my max minus my min, and then it calculates right here. Then when you grab your data, I'll show you how I can replicate. I'm going to make a new one of these out to the left. I grabbed all my data. Whoops. Put down here, grab all my data. And then I'm going to say insert. I'm going to insert, and then I'm going to click on this bar looking thing. And then I'm going to go to more column charts, and actually it's going to bring up everything. And I'm choosing histogram. It's down here towards the bottom right here, histogram. And then I'm going to click on that one and hit OK. And then it looks a little bit different than what we came up with. So I wanted mine to go by 2s. So I'm going to click on the plus button right here, and it gives me options for chart elements. I'm going to go to the axes and click on that black arrow, and then I'm going to click on more access options. And over here to the right, it's letting me choose either the number of bins or the bin width. And I want my bin width to go by 2. And that's just what I've chosen. I'm going to click away from that and exit out of it. And then it will match the one I already had occurred. And you can see the groupings down here at the bottom. Okay. Then you can see, I would like us to do, the next one is on shoe size, and that is this data here. So it says the following data are the shoe sizes of 50 male students. The sizes are continuous data since shoe size is measured. Construct a histogram and calculate the width of each bar or class interval. Suppose you choose 6 bars. Okay. So I'm going to go back to my Excel, and I want to choose 6 bars. So I'm going to divide by 6. I took my range, which is my maximum value, to my minimum value. The largest shoe size somebody had was 14, and the smallest was 9. And so my width is 0.833. So I could go by ones in here. I had them going by 0.5s. So I'm going to do and just show you the difference of if you go by 0.5 or by 1. I'm going to say insert. And oops. Oops. There we go. Click on the histogram. Okay. Okay. And right now it's going a little bit differently. So I'm going to change this axis to go by ones. The bin width, and I'm going to have it go by 1.0. And you can see it looks just a little bit different shape. Over here, I'm going by 0.5s, and over here, I'm going by ones. So it definitely changes. Let's just change this. Bin width of 0.5. And then let's just do that. There we go. So this one is 0.5 and this is 1.0. So you can just see the difference in shape there. Okay. The next data set that we're going to look at is the number of hours playing video games on weekends. And I'm going to just show you that on my screen or on my paper here. We've got this data here, number of hours my classmates spent playing games on weekends. And you can see that the smallest data point was a 0. So that's what we started at. And the largest was up to 24, I believe. And so conveniently, we went by groups, bin width of 5. And so our last bin goes up to 25. And the last one that you're going to try here in this type of plot is the following data represent the number of employees at various restaurants in New York City. So I give you the data here. I'm asking you to find using the first interval of 10 to 19. So that's going to set it up. And there's a link for a Desmos link because I did this in Desmos. I want you to see that there's other ways besides Excel that you could do these. So if you go here and click on the Excel, it will take you to that right here. And you can say that if you want to as Math 201, lesson 2.2, and this was video game. And so if you go down here to the menu, if you want to find this histogram command, you go down to the menu and over here to the right under functions and scroll down and you'll see under visualizations, there's a histogram, a dot plot, and a box plot. And we're going to use a box plot in lesson 2.3. But you can tell it to use counts, you can tell it to use relative if you want, which would be percentages, and you can have it center or you can have it left. It's wherever you'd like it to go. And up here, I told to use the data in column X1, and then the right hand is the bin width. So I wanted to do bin width of 10 because it was going from 10 to 19. So that's how that worked. And so let's look at our next type of graph. Frequency polygons are another graph. It looks kind of like a line graph that we're going to make with continuous, quantitative continuous data. Frequency polygons are analogous to line graphs. Just as line graphs make continuous data visually easy to interpret, so too do frequency polygons. To construct a frequency polygon, first examine the data and decide on the number of intervals or class intervals to use on the X and Y axis. After choosing the appropriate ranges, begin plotting the data points. After all the points are plotted, draw line segments to connect them. They are similar to line graphs, but they have a fake first class that touches the x-axis. And I'm going to show you that here in the notes. So you can see where we are going to, when we put our data in, this one I've already created for you, but the markings for the frequencies, you can see the dot here at 54.5, that frequency is 5, because there are a frequency of 5 that fit into that first bin of 49.5 to 59.5. And I make those dots markings at the midpoints, okay? And so I'm going to show you how to find your midpoints here in just a minute. The one unique thing is notice that this 44.5, we don't have any data there. That's a fake first class. I don't show it in this table, but I do in the next one. So let's look here at the, it says construct a frequency polygon of US presidents' ages at inauguration shown in the table. So I created this fake first class where I have a frequency 0, and I'm finding the midpoint for that fake first class by taking my lower, this 36.5 plus my upper 41.5 and dividing by 2 so I can find the middle, which is 39. Now I'm going to show you how I did that in Excel here. So I put in my lower boundaries, my upper boundaries, and I put them in separate columns so that I can use them. So here, if I click on my midpoint, you'll see my calculation. I clicked on A3, I clicked on the 36.5 and it put in A3 for me. And then I hit plus, and then I clicked on the cell B3 for 41.5 and it put that in there. I added them in parentheses and divided by 2 to get the midpoint. And then if you grab onto that little green dot and drag it down, so if I were to delete these for just a moment, I can show you if I grab this little green dot and drag it down with my left mouse button, it will fill those in, repeating that same calculation with the next row's numbers. And you can see that the width is a consistent 5 between each of them. And then when you go ahead and do this one, you're just going to choose the line chart works again. Okay. Frequency polygons are also used nicely for comparing distributions. This is achieved by overlaying the frequency polygons drawn for different data sets. So I'm going to show you how we compared one with calculus final test scores with their actual final grades in the class. So I have the same lower and upper bounds, and then I just put them in their frequencies. So I can see that I had 5 students that scored in the 50s to almost 60s on the final exam test, but I actually had 10 students that scored in there for their final grades. And so I just overlaid them on my line chart. And for the most part, I won't be asking you to create any of these for a midterm or a final. It'll be, I might give you some graphs and have you read them. And the last type of plot that we could do is called a time series plot. To construct a time series plot, we must look at both pieces of our paired data set. So time series means that we have data based on time. As in here, you can see this is a consumer price index per month for 10 years. So it was January, the consumer price index was 181.7 in January of 2003. So we start with a standard Cartesian coordinate system. So you can do an XY like you would in an algebra class if you want, but you can put this data into Excel and it will give you some options. You can play around the graphs and create this one. So we're going to do this. You try it here. It says the following table is a portion of a data set from the worldbank.org. Use the table to construct a time series graph for the CO emissions for the US. So we want to only just create the time series for these years and the values for the US. So we're going to put the years in one column and the US emissions in the other. So I'll show you, it's in our spreadsheet that you're using. And all I did was I grabbed the data. Oops, I grabbed the data year in US. And then I went up to insert. And then you can do recommended charts. A lot of times with your data, it will kind of know what would be good. So you could do this line graph or you could do the scatter plot. They look for the most part about the same, except for the grid looks just a little bit different. So you can see that I chose the line graph for mine, where the years are on the horizontal and the values are down here. Now, really the scaling should be starting at 0 for a good graph. So we should go in here and say more options. Oops, no, and have it start at 0. I will change that for you. So that is all for lesson 2.3. Go ahead and, I'm sorry, for lesson 2.2, go ahead and catch me back for 2.3. See you in a bit.